Hi folks, this is the solution to 2c from page 582. So they want us to find the derivative of this function, and again you have to notice here that I've got a power with a base and exponent that both have a variable in it. Okay, so as soon as I see anything like this, I need to think about logarithmic differentiation. So I'm not going to be working directly with x to the root x. I'm going to be working with the natural logarithm of this expression. Okay. Now again, the reason why we work with this expression instead of x to the root x is this allows me to use a ski-slope rule and take that expression with a variable out of the exponent. So I can rewrite this as square root of x times ln x. Okay, and so now I can differentiate this, both sides of this equation. Okay, so I'm going to take the derivative of both sides. Okay, and the reason why this works is because on the right hand side, nice and easy, just a straightforward, this should be square root of x times ln x. Okay, straightforward product rule problem. And on the left hand side, part of what's going to come out of taking the derivative of the left hand side is going to be the derivative that I'm actually looking for. Okay, so let's go ahead and do the left hand side. So here I'm going to use the chain rule because I've got a composite function. So this whole thing here is going to be my u. So what's the derivative of this? Well, it's the derivative of ln u, which is just 1 over u. So 1 over x to the root x times the derivative of u with respect to x. So the derivative of x to the root x with respect to x. And of course, this is exactly the thing that I'm looking for in this problem. That's what I'm trying to find. Okay, and on the right hand side, I'm just going to apply the chain rule, the product rule. Okay, so derivative of the first, so derivative of root x. So again, we've done this quite a few times, so I'm actually going to write it in simplified form because this is 1/2 times x to the negative 1/2. So that negative exponent is going to bring everything into the denominator. So 1 over 2 root x, okay, times ln x, okay, plus the first function, root x, times the derivative of the second function, which is just 1 over x. Okay, and now I can just solve for the expression which I'm actually looking for. So the derivative of x to the root x is given by, this just gets multiplied to the other side, so x to the root x times this whole thing here. Okay, so in principle, I would just say, leave it as it is. If you're being asked to not simplify, you would just leave it as x to the root x times this whole expression. But just to now start getting some familiarity with doing some more simplification, let me do that here. So here I've got ln x over 2 root x, and here, well, this is x to the 1/2, and that's x to the 1. So we can actually simplify that using our quotient rule. So 1/2 minus 1 is negative 1/2. So this just becomes 1 over root x. Okay, and that'll be something pretty easy to add. Okay, so here my common denominator is going to have to be 2 root x. So I've already got that in the first expression, so that doesn't change. But I'm missing the factor of 2 in the second denominator, so I'll have to multiply that there, all over 2 root x. Okay, so this would be the derivative in simplified form. Okay, but just to recap, because what's nice about logarithmic differentiation when you have a power is it's exactly the same thing every time. Once you recognize that there's a variable in both the base and the exponent, you work with the natural logarithm of that expression, which allows you to rewrite it using the ski-slope rule. And then you take the derivative of both sides, and what you need comes out of that process.